right, hi everyone. So think back again to what we learned yesterday. So we talked about how to solve the last 2 days, how to solve 2 by 2 systems of equations. Okay, so 2 by 2, remember, is two variables and two equations, right? That's what makes it a 2 by 2 system. So if we said for this unit, we're going to be focusing on how to solve 3 by 3 systems of equations, how many variables do you think it would have, and how many equations do you think it would have? So it would have 3 variables and 3 equations, right? So we just increased each number by 1, so we have one more variable and one more equation. All right, so we learned how to do graphing with that. We learned how to do substitution and elimination, or it might have just been a review for you. So for 3 by 3 systems, we're going to look at how to use elimination and substitution again. And then instead of graphing, we're going to look at how to solve this with matrices on the calculator, all right? And we're going to do that tomorrow. So today we're just focusing on elimination and substitution with 3 by 3 systems, okay? First, let's look at this word problem, okay? So if you'll remember on Monday, we looked at some word problems and how we would come up with some systems of equations. So this is specifically a 3 by 3 system word problem, okay? I'll read it to y'all, and then we're gonna come up with a system of equation together. All right, so Billy's restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. How many of each type of flower was ordered? So I don't know about y'all, but that is a lot of money to spend on flowers. Okay, but let's look at first, what are we trying to find, right? So if you remember on Monday, what we were trying to find or figure out was how much each item cost. What was the cost for each item? And that was going to be our variables. So here we're trying to find how many of each flower type was ordered. Okay, so we're trying to figure out how many roses did they order, how many carnations did they order, and how many daisies did they order. Okay, so we don't know that, so that's going to be our 3 variables. So let's write our variables down. All right, let's make our variables C for carnations, and then we have R for roses and D for daisies. So those are our 3 variables, C, R, and D. Okay, so let's try to build our equation now. So first thing I would suggest looking at is, do they give you a total for how many of all the flowers they ordered in total, right? So at the very first sentence, it says they ordered 200 flowers. So although we don't know how many of each flower they ordered, we do know that in total they had 200. So that means our first equation can just be carnations plus roses plus daisies equals $200, okay? So then we're going to write that as our first equation. C plus R plus D equals 200. That is our very first equation. We have 1 down, we need 2 to go, okay? All right, so let's look at, next it talks about the prices for each one of them. Then it says they ordered mostly carnations. So if they ordered mostly carnations, that means most of that 200 was carnations. And then it says they ordered 20 fewer roses than daisies. Okay, so that means if we subtract the amount of roses, which we don't know, that would be R, right? If we subtract R from D, what is that going to equal? It's going to equal 20. So that can be our second equation, right? So if we subtract D minus R, because they have 20 fewer roses, that's going to equal 20. okay? So even though this second equation doesn't have all three variables, this can still help us. All equations don't have to have all three variables, okay? All right, so now we need one more. So what other piece of information or pieces of information have we not used? So what we haven't used yet in particular is the total for money that it came to. So their total order cost $589.50. All right. And then we know the price for each type of flour, although we don't know how many flours of each kind they got. So we know for this third equation, our total, or what it equals, is going to be 589.50. Okay. And then what would we write to the left that would, if we add up, would come to that total? All right. So we're going to multiply each of those variables by how much each individual flour costs. So each individual carnation cost $1.50. So we're going to have 1.50 C. And then for each rose, it costs $5.75. So 5.75 R. And I'm going to squeeze right here, plus Daisy's was 2.60 D. All right, so, and that's going to total up to the total amount they spent, all right? So those are our three equations right here. That is our 3x3 systems of equations, okay? So as you see, we have three equations, and we came up with three different variables we could use from the word problem, all right? So that is how we would build that. So now what we're going to look at is how we are going to solve 3x3 system with substitution and elimination first, all right? So you have this 2D notes, okay? You have this 2D notes in a PDF in Schoology. All right, we have some problems listed for us to go over. So let's do one of each so y'all can see how it goes, and then y'all can finish the rest. All right, so let's look at these 2D notes. Okay, so, and this is supposed to say 3x3 systems on the top instead of 2x2. That's a typo. 3x3. Okay, because we're looking at 3x3 systems. We know this is 3x3 because why? Because it has three equations and three different variables, x, y, and z, all right? So what we're going to do is kind of very similar to how we did elimination with a 2x2 system, okay? So what we're going to do is pick two different sets of equations, use elimination on them, so that we can narrow this down to a 2x2 system and solve for the variables, all right? So in each one of those sets, you're going to want to eliminate the same variable. So let's pick, it doesn't matter which ones you pick, you can just pick whatever looks easier to you, whatever you want to do. I'm going to pick the top one and the bottom one, okay? And then to make those x's cancel out, because I'm going to eliminate the x's, we're going to make one of them negative. So let's multiply this bottom equation by -1, okay? So first equation we have is x plus 2y equals -2, or pardon me, not equals, minus 2z equals -15. Okay, and then we're going to multiply the bottom equation by -1, so we're going to have -x plus 4y minus z equals -18. Okay, so now we can cancel out our x's. So boom, those are gone. Okay, and then we're going to combine everything else in those two equations. So 2y plus 4y is 6y. -2z minus z is -3z. And then -15 minus 18 is going to be -33, I believe. Yes. All right. So that's the first equation that we're going to use in our 2x2 system. So I'm going to box that in. So we remember to use that, keep that there. All right, so let's pick a second set. So I would suggest using the equation that you didn't use already, okay? and then just pick another equation that would go well with that. So we're going to use our second equation right here, and then let's use this top one. Okay, so we have those x's that we need to eliminate again because we need to eliminate the same variable. So what I'm going to do is multiply the top equation by -2 to get -2x, the opposite of 2x, okay? So let's write the equation we didn't change, the middle one, which was 2x plus y minus 5z equals -21. Okay, and then the top equation, multiply everything by -2. So we have -2x minus 4y minus 4z equals 30, positive 30. Okay, awesome. Oh, and that was supposed to be plus 4z, right? Negative times negative makes a positive. Okay, awesome. So there we have our two equations for that one. So we can cancel out those x's. They make 0, so they're gone. Let's combine everything else. So y minus 4y is -3y. And then we have -5z plus 4z. So that's going to get us minus just z. And then on the end, we're going to get a positive 9. All right, so there's our second equation, and then we'll box that one in. So remember it's there. So now with the two boxed in equations, we have a 2x2 system, don't we? Okay, so that's what we're going to use to do another round of elimination that will help us solve for our variables. All right, so I'm going to erase everything else except those two boxes to give us some more room. All right, so then we have those two equations. So what variable, we have both y and z in both, what variable could we easily eliminate? I think I'm going to pick to eliminate z, okay? Doesn't matter which one you pick. I'm going to pick z, so that means we have -3z in one and -z in the other. So let's multiply this bottom equation by -3 so we can change that -z to positive 3z, okay? So let's try this elimination. So up here, we're going to have this red equation first. So 6y minus 3z equals -33. Okay, and then our second equation, multiply everything by -3. So we have 9y plus 3z equals -27. Awesome. Okay, so now we can cancel out those z's. Okay, they make 0, so they're gone. Let's combine everything else. So 6y plus 9y, that's going to get us 15y equals, and then 33 and 27, it's going to give us -60, okay? And then all we have to do to get y by itself is divide each side by 15. Okay, so -60 divided by 15, it's going to get us -4. All right, so that is our y value there, okay? So now what did we do when we had one of our variables, but we still needed the other ones in the 2x2 systems? What did we do? All right, we plugged that variable that we had solved for back into the equation to find the other one. So let's plug this y back into one of these boxed equations to find z. So I'm going to pick this purple one down here since z is only negative and it doesn't have a coefficient in front of it. So let's plug y in there. So we have -3 times -4 for y minus z equals 9. Okay, -3 times -4 is going to give us positive 12. All right, so 12 minus z equals 9. And then we're going to move that 12 to the other side by subtraction. So subtract 12 from both sides. That gets us -z equals -3. All right. Now to get rid of that negative on the z, we just divide both sides by -1. So our answer is z equals +3. Okay, so now, so far we've solved for y and z. What variable do we still need to solve for? X, right? So all we're going to do is take our y and our z, plug it back into one of our original equations, and solve for x. So I would either choose the first or the last one because x doesn't have a coefficient or a negative in front of it. Okay, so I'm going to erase some stuff right here. Okay, keep that z equals 3 so we remember. All right, so let's use the first equation. So we have x plus 2, and then our y was -4, minus 2, and then our z was 3, equals -15. Okay, so we have x plus 2 times -4 is -8, so that's, instead of a plus, that's going to be a -8. All right, and then 2 times 3 is 6, so -6 equals -15. All right, so we're going to combine that -8, -6, so that gets us x minus 14 equals -15. So add 14 to both sides, and we're going to get x equals -1. All right, so our solution, let me double box those. Our solution is x equals -1, y equals -4, and z equals 3. Okay. All right, so after you've completed your notes on that first elimination problem, go ahead and complete the rest of the elimination problems after that. So pause this video and work on those, and then come back to start to learn how to do substitution. All right, so we're looking at substitution now. So it's kind of the same thing we're going to narrow it down to be a 2x2 system instead of 3x3, so that it's easier to solve, okay? So what we're going to do first is pick one of these equations and just pick that equation and solve for one of the variables in that equation. Doesn't matter which one. All right, I'm going to pick this third equation because I'm going to solve for y, because y doesn't have a coefficient and it's positive. So all I kind of need to do is move stuff to the other side to get y to be by itself. All right, so all I need to do is add the 6x and add 7z to the other side and to get y by itself. So that's going to be y equals 6x plus 7z minus 12. All right, so there is that solved for y. Now what we're going to do with that is plug that in, so substitute this whole thing, which equals y, into this y in this equation and this y in this equation. Okay, so plug that back into the other two equations and we'll see what happens. All right, so we're going to take that. So our first equation was, so we have 2x plus 5, and then for y we're plugging in what we got for y on the third equation, so 6x plus 7z minus 12. All right, and then plus 2z equals -38. All right, so now all we have to do is simplify that. So let's distribute that 5. So distribute it to those three things. So we have 2x plus, we're going to have 30x. Then we're going to have plus 35z. And then we're going to have minus 60. And then we have, after that, plus 2z equals -38. All right, now all we have to do is combine those like terms within that equation. So I see two different x terms. So we can add the 2x and the 30x to be 32x. Okay, then we have two different z terms. So add 35z and 2z. It's going to be 37z. Okay, and then that -60, we can move to the other side. Right, so add 60 to both sides. Okay, so it goes away on the left, and then 6D minus 38, it's going to get us positive 22. All right, so that is our first equation that we're going to want to hold on to. So I'm going to box that in right there. Okay. All right, so that's that first one. Now I'm going to erase that work right there. Okay. And we're going to plug what we got for y into the second equation. Okay, so let's see what the second equation says. All right, so our second equation is 3x minus 2. And then for y, we're plugging in 6x plus 7z minus 12. And then plus 4z equals 17. All right, so first thing we're going to want to distribute that to all three of those things. So we have 3x minus 12x minus 14z, and then plus 24. Okay. All right, and then we have plus 4z on the end equals 17. All right, and then we combine like terms within. So I see 3x minus 12x. That's going to get us negative 9x. And I see negative 14z plus 4z, so that's going to get us negative 10z. And then we can move that positive 24 to the other side. Okay, so we're going to have 17 minus 24. All right, so that's going to be negative 7. So there's our second equation that we're going to want to hold on to. We simplified it as much as we can. Okay, now what we're going to do with those two equations that I've boxed in black is we're going to use substitution on those, okay? Really, we could use any way to solve them, right? Because now it's just a 2x2 system, okay? But we're going to use substitution again. All right, so what we're going to want to do is choose one of those equations. I'm going to erase this work up here so we have some room. Choose one of those equations and pick a variable to solve for. So let's see what could be easy. Let's solve for x in the first one, okay? So we're going to solve for x in the first one. All right, so what we're going to have to do first is move that negative 10z to the other side. So now it's going to be negative 9x equals 10z minus 7. Okay, then we divide both sides by negative 9. So we have x equals 10z minus 7 over negative 9. Okay, so that is that equation, solve for x. And then what we're going to do is plug that in to the second equation and solve for z, okay? All right, so I'll box that in so we have that information. Okay, we're going to plug that into the second equation and solve for z. All right, so first thing we have is this 32. All right, and then we have x, and what we're plugging in for x is that negative 10z minus 7 over 9. Okay, and then we have plus 37z equals 22. All right, so let's distribute that 32. All right, so what we're going to do is just distribute that 32 to these two top terms. So the negative 10z and then plus 7, okay? So 32 times negative 10z, it's going to get us negative 320z, big number, okay? And then if we distribute this negative that was in front right here, that's going to be a plus 7, okay? So 32 times positive 7, it's going to be 224. And then that was all over 9, okay? And then we have plus 37z equals 22. All right. Okay, so then what we need to do is move that 9 to the other side. So how we do that is dividing that section right now is we're going to want to multiply both sides by 9. Okay, so if we multiply both sides by 9, this 9 is going to cancel out, but we also need to multiply that 37z by 9. Okay, so 37 times 9, it's going to be 333. Okay, so I'm going to move my work over here. So we have negative 320z plus 224, and then we said 37z times 9 is plus 333z. Okay, and then we multiply the right side by 9. It's going to be 198. Okay, so now all we have to do is combine our like terms. So combine those z terms together. So 333z minus 320z. We're going to get 13z, positive 13z. Okay, then we're going to move that 224 by subtraction to the right side. Okay, so we're going to have negative 26 on the right side. Okay, then all we have to do is divide 13 on both sides. So z is going to equal negative 2. All right, so a little bit of work to get there, but we got there, right? Z equals negative 2. Now, what did we do on the last problem with elimination once we had one solution? All we did was plug that solution into some equations and found the other ones, right? So let me erase my work a little bit so we can see what's going on. So we're going to use that z equals negative 2, and let's plug it into the top equation in green, boxed in with black. So plug that in, and then we'll solve for x, okay? So let's see, we have negative 9x minus 10, and then for z we have negative 2 equals negative 7. All right, negative 10 times negative 2, that's going to be positive 20. And then we can move that over to the right side by subtraction. So negative 7 minus 20 is going to be negative 27. Okay, and then we need to divide both sides by 9. Negative 9, actually. So x is going to equal, if we divide both sides by negative 9, positive 3. And there we have our second one. So now, once we have the two variables, we just plug it back into one of our original equations and solve for the third one, which would be our y. Okay, so I'm going to erase this stuff right here. And let's plug those two back into one. So let's plug those back into the third equation since y doesn't have a coefficient and is positive, okay? So we have negative 6, and then x is 3, plus y minus 7, and z is negative 2, equals negative 12, okay? Negative 6 times 3 is negative 18, plus y. Negative 7 times negative 2 is positive 14. Okay, so we can add that positive 14 and negative 18 together to get negative 4, and then add 4 to both sides. Okay, so then we have y equals negative 8. And those are our three solutions. X equals 3, y equals negative 8, and z equals negative 2, right? So go ahead and finish the rest of those substitution problems, doing it just like how we did it, okay? Then once you've done that, there's going to be an exit ticket up on Schoology for you to finish, and I'll see you guys tomorrow.